Hello, my name is Vladimir, and I'm here today to briefly describe some possible ways for the deployment of Siesta DFT code. How to get it as a ready-to-use plug-and-play solution for educational purposes, for example, as well as which steps are necessary to build it completely from source. Apart from these topics, I will also mention a couple of systems aimed to help in compiling Siesta together with its dependencies. This material is explained in more detail in the tutorial section of the Siesta documentation under this link. Please keep in mind that my talk will be in no way an exhaustive list of all possible ways to build and deploy Siesta. Many are under development in various research groups and hopefully will end up in the tutorial section. Please consult the official Siesta manual and documentation section for the updates on the topic. Let's start. As Siesta is a big and complex tool aimed primarily for the high-performance computing, it can also be quite tedious and even frustrating to install for the beginners. This is one of the reasons there exist a number of ready-to-use plug-and-play options where one can use a pre-installed Siesta in a virtual environment. First such environment to mention is the Quantum Mobile virtual machine, containing several DFT codes curated by MAX and Marvel European initiatives, including Siesta, as well as the AIDA instance that can orchestrate all the codes present in the virtual machine. Quantum Mobile comes in several flavors. One of them can be easily installed through VirtualBox as the Linux desktop, which can be very useful for beginners. Please look up the Quantum Mobile website as well as our tutorial section on how to use Quantum Mobile through the VirtualBox. In such cases where more lightweight virtual environments are preferred, containers like Docker and Singularity can be used. In our group, we have a set of experimental Docker containers for Siesta, and we plan to auto-generate them on a regular basis with future releases. This slide shows an example invocation of such a container, where the local folder is mounted as a volume through the -v flag inside the container under the specific root. This folder will persist after the Siesta run is finished, and the output files will be saved on the host machine. Singularity is another container system, more oriented towards the high-performance computing codes. And although we also have some experimental images for Singularity, it is arguably more handy to use the existing set Docker images to convert them directly to the Singularity images. Example is also shown on this slide. Note that when Singularity container is launched, there is no need to mount your local folder as a volume inside the container. This is done automatically. And this is one of the improvements of Singularity over Docker that can make your life as a researcher easier when you use this type of containers. Although virtual solutions can prove very useful to make your first steps with Siesta, often serious calculations require custom build of Siesta code from source. This section is best explained in first two chapters of the Siesta manual, but I'll give a brief overview of the main steps required. It is recommended to get the Siesta code archives from the releases section on the GitLab project page. After obtaining the source, a distinct build directory has to be created. You can use the default OBG directory, or you can create another one, but it's not allowed now to compile Siesta directly in the source code. So you need to make a separate directory and use this shell script to bootstrap it. Next step would be to place an archmake file inside this build directory, and it is handy to use the new templates that are present in the default OBG. And then you need to edit the archmake because the main user configurations are actually all assembled there. After the archmake is in the good state, you need to compile it with make, and optionally to build the utilities suite that are all located in the util subdirectory, and there is also a shell script present to build them all. The said archmake configuration script is used for mainly three things: to define a set of external dependencies that will be used for the build, to provide the linking paths and symbols for those dependencies, and to configure the compilers and flags for compilers. All possible customizations of the final executable can be controlled through the configuration of the archmake file, and good news are that now we also have very detailed self-explanatory templates where the user needs to edit only the header, and they have clear instructions in the comments how to do so. As for the dependencies, please also note that they differ among themselves and fall into two categories: ones that are common for many HPC codes and scientific research codes, and most likely be pre-installed by your system administrators and pre-configured on your host machines, and those that are Siesta specific and are most likely not to be very well known. The home for all those Siesta specific libraries is the section on the Siesta project repository on GitLab, and it is also important to mention that Siesta comes with all the necessary dependencies bundled with it, so those that it does not carry by default are optional and provide some extra experimental specific features for Siesta. Even MPI driver is optional here, because in principle Siesta can be compiled and run in serial mode. But when MPI is used, one needs to specify the location of Scala pack for Siesta to compile and link against it. One notable features of Siesta are support for the array structured data files through the netcdf library, interface to the standard external exchange correlation functional library, support for external solvers through the electronic structure in infrastructure, fine control of the calculation in the runtime with the Lua script, and the support for the new PSML pseudopotential file format. And though, as I said, all these features are optional, together they make Siesta a very powerful research suite. So, as you can imagine, an accurate management of dependencies and build environment for Siesta, as for a number of other scientific codes, can be quite cumbersome. For that reason, several scripted systems exist that allow to streamline the compilation process. Such systems differ greatly in complexity and operation quality, and I will name a couple to compare. First to mention is the Siesta install scripts repository by members of our group, Alberto Garcia and Heshu, and it is merely a set of makefile scripts and shell scripts that consistently build Siesta along with a set of dependencies all together. It is hosted on GitLab, and you can have a look at it, you can try it out. It is quite well documented with the README files and inline commentaries. The general operation mode is listed in this slide. You need to download and enter the archive and edit a bunch of scripts along the commentary hints, so that alongside them the dependency libraries and Siesta will be built consistently. The steps are actually very much like the steps I described above, so editing a lot of script files. And this project can be not only a good example, but it also can suit some system administrators in the environments where only the default toolchain and standard Linux, Unix utilities. And on the other side of this spectrum are complex package managers such as SPAC, for which in our group we also have an experimental Siesta package. Note that this is not yet in the core SPAC repository, so to use it one has to clone a specific branch of my fork of SPAC. And after all the necessary configurations, the installation of Siesta in principle should be a one-liner. At least this is the ideal situation which we are heading towards. So here is basically a trade-off situation where in the complex tool that is quite hard to set up and also needs some habit to use, the installation isn't very simple, while in the basic tool you need a lot of configuration done manually. And this is all for a very brief and fast introduction on the ways how to obtain or build Siesta. Once again, I advise you to look for more detailed explanation on the official Siesta tutorials and documentation section. You can find them using these links. Also, and maybe first and foremost, please address the Siesta manual. And if any questions remain, check out the Matter Modeling Stack Exchange subforum. Search for the tag Siesta. Thank you for using and learning Siesta. If you have any questions regarding the installation topics, please feel free to contact me through the official event channel of the Siesta School. I will be a tutor during the summer school. So you can find me on Discord, and also you can write me an email. Thank you again and enjoy the Siesta School.